Okay, I want you to open up to this page in your Padlet and try as much of numbers 1 through 4 as you can. Pause the video here and try as many pieces of 1 through 4. Okay, so drawing your angles, you have to draw the initial ray on the positive x-axis. Rotate counterclockwise for the terminal ray, and here is our angle of rotation. The reference angle, when acute, is going to be the same angle. Coterminal means same terminal ray. So we could go all the way around the circle and back to that terminal ray. So that's 39 plus 360. And then we could also go in the clockwise direction. Whoops, wrong starting point. Always start on the initial ray. So we can go this direction, and that would be 39 minus 360. So we're going to add those up. This is 399 degrees. And then 360. Oh, pen is not working well. 360 minus 39 would be 321. This is going to be negative 321 degrees. Symmetric angle is, if you think of the Ferris wheel ride, would be the angle in this direction that has the same height as the 39 degrees, because sine is based on the y. So this angle of rotation here is going to be 180 minus 39 degrees. Let me try my pen again. 180 minus 39 degrees. So that is 141 degrees. And number 2, that initial ray, terminal ray. And so your reference angle is this acute angle. So that is 180 minus 125, which is 55 degrees. For coterminal, you should have done 125 plus 360 and calculate that, and 125 minus 360 and calculate that. Symmetric, that would be the angle in quadrant 1, which is 55 degrees, which is whoop, come on, Ben. The ray here with the same y value because of sine. Okay, 260 degrees. We've got initial ray, terminal ray, and your reference angle is always the angle to the x-axis, never ever the y. It's always this x-axis, this acute angle to the x-axis. So the reference angle in number 3, to calculate it, we're going to do 260 minus 180, which is 80 degrees. Coterminal, we've got the 260 plus 360 for an extra full rotation in the counterclockwise, and 260 minus 360 in the clockwise direction. Symmetric would be the angle in the fourth quadrant, which is down here, the same y segment. So using that reference angle, we're going to do 360 minus 80. Which would give us this angle of rotation. Or you could say negative 80 degrees and go clockwise, which is this angle of rotation. All right, last one. We've got initial ray, terminal ray. Here is the 341 degrees. So your reference angle is going to be 360 minus 341, which is 19 degrees. Co-terminal, we're going to take 341 plus 360 and 341 minus 360. So when you did the warm-up, you should actually be calculating these values out. And then symmetric angle, I can either say negative 19 degrees to put, oh no, that's co-terminal. No, miss these, we don't want that. We want an angle over here in the third quadrant. So I need this angle of rotation. Which is 180 plus 19 for a grand total of 199 degrees. And there we go. You could use numbers 5 through 8 as extra practice. Those answers will be in Drive when the notes are posted. Okay, now I want you to turn to page 24 at the bottom where it says part 2. We're going to continue on with the Carlos and Carlita situation and their Ferris wheel ride. Carlos and Carlita decide to ask their math teacher how mathematicians have defined sine for angles of rotation, since the ratio definition doesn't hold when the angle is not part of a right triangle. Here's the summary. I want you to circle this, put a star. This is our definition of angle of rotation and angle terminal ray and initial ray. So the teacher said, we begin with a circle on the radius, with a radius of r, whose center is located at the origin. On a rectangular coordinate grid, that's just our XY axis. We represent the angle of rotation in standard position with the vertex at the origin. The initial ray is along the positive x-axis. The terminal ray rotated theta degrees. Counterclockwise is a positive angle. Clockwise is a negative angle. So now if you turn to the back, we've got this diagram. In this diagram, theta is between 0 and 90 here, with a terminal ray in quadrant 1. I want you to label your picture. If we have, this is the radius and this is our point, what's this leg in terms of x and y, and what's this leg in terms of x and y? So the horizontal is x, up is y. Whoops, not two of them. And based on this diagram, what is the sine ratio? What is the fraction for sine? Pause the video here and write out your fraction for sine. Okay, so you should have had y divided by r. The sine ratio is y over r in this picture, since the y is opposite and the r is the hypotenuse. We can now use y over r as the definition for sine for any angle of rotation, no matter which quadrant our terminal ray falls in. So let's try it. Consider the point -3, 4, which is on the circle x squared plus y squared equals 25. In geometry, the equation of a circle was x squared plus y squared equals r squared. So a circle with the center on the origin will always have the form of the equation x squared plus y squared equals r squared. Based on that, what is the radius of this circle? Pause the video and write out, what is your radius? You should have written the radius is 5, because if r squared is 25, the radius is 5. So let's draw that circle. Put a point on your grid at every 5 on all the axes. I'm going to use my circle tool. Oops. All right, so there's our circle, radius of 5. And let's plot this point, -3, 4, right here. Here's our terminal ray through that point, initial ray, positive x-axis, draw a circle, okay, and then this is the angle of rotation. For the angle of rotation, which just drew, what is the sine ratio? You're going to say sine of theta. I wish my pen worked. Sorry about this. All right, sine of theta is, what is your fraction? Okay, so you should have had 4 over 5. Oops. All right, 4/5. How did I get 4/5? So sine is y over r. I draw the triangle here. This is left 3, up 4, radius of 5. And we get this y over r for 4/5. Using your calculator, let's solve this to get the angle of rotation. Think back to the very first day of the unit. How did we solve this equation with our calculator? All right, so you should be thinking sine inverse. Sine inverse undoes the sine ratio, sine function. So if we do sine inverse of 4/5, we will get theta. In your calculator, type it now. (53.1 degrees). Oops. But is that this angle of rotation? The way we have our circle up here, this theta looks like it's obtuse. So this 53.1 is the reference angle. Label that as the reference angle. It is not the angle of rotation. The calculator gives you the reference angle. You are smarter than your calculator. The calculator does not know which quadrant you're working in. So you have to know, hey, calculator is giving me this acute reference angle. So to find the angle of rotation, I'm going to do 180 minus 53.1. Oops. And we get 126.9 degrees. So look at our picture. Does it make sense that this angle would be 126.9? It does. That makes sense. All right, so we got one more question on the next page. I'm going to bring this information over. The read part E on page 26 while I go get my little equations. All right, is the calculated value the same? So let's try this. If I do sine of 126.9, is that the same as 4/5? Yes, that's really close because this 126.9 was rounded because I rounded this 53.1. So yes, the calculator, so is the calculated value based on this definition the same? Yes. But when using the calculator to solve for an angle, I only get the reference angle, which is not necessarily the angle of rotation. Oops. All right, let's try number 10. Consider the point -1, -3. That's down here. Initial ray, terminal ray. What is the radius of the circle? Pause the video, figure out your radius. All right, your radius should be the square root of 10 because x squared plus y squared equals r squared. So if r squared is 10, that means r is root 10. Not plus or minus, because now we're dealing with a segment of a circle, a radius of a circle, it's going to be positive. All right, our angle of rotation, whoop, all the way around to the third quadrant. What is sine of theta? I'm trying to write with my mouse, that's so sloppy. Okay, sine of theta, what would that fraction be? What is the y over the r? You should have -3 over root 10. I think of this triangle. Here's my -3. The radius here is root 10. All right, what is the angle of rotation? Solve that now in your calculator. Negative, it says theta is -73.6 degrees, 71.6 degrees. Now, wait a minute, -71.6, that's in quadrant 4. Our angle is in quadrant 3. So this -71.6, the reference angle is just +71.6 degrees. Next year in pre-calculus, you're going to have a whole unit on inverse trig functions. So this negative for now from the calculator, we're going to ignore it because quadrant 3, I just need this reference angle, and next year in pre-cal, you'll get more details on that negatives for the angle when you solve the inverse. All right, now use 71.6 to find the angle of rotation. Pause the video to do that. You should be doing 180 plus 71.6. $251.6 degrees. The last one is the sine is the calculator giving us the same sine value. So sine 251.6, -0.94. 8876, so on, so on, so on. So if I do my y over r, is that the same? Yes, pretty close since we rounded. This is correct to 3 decimal places. Yes, calculator gives the correct ratio. But I've been using the calculator to solve for the angle. I get the reference angle and not the angle of rotation. We have to use our brains to find the angle of rotation, not just take the calculator answer as the exact answer. Okay, your homework is page 27 and 28. On the calendar and drive, there's this help video to help you set it up. It is a no calculator homework. Do not type each expression in the calculator to get an answer. If you are totally stuck, start with this video and work through the first problem with the video, and then you try the second problem on your own.